Okay, we're going to look at question 1 here. We have x plus 7 over 11 plus x plus 6 over 11. Now, notice these fractions are like here, meaning we have the same denominator. (11) and 11, so they're like fractions. All we need to do is perform the operation that they gave us here, meaning we just have to add the numerators together and divide by that denominator of 11 here. So at this point, we're going to combine like terms for the numerator. And so we have x plus x will give us 2x. And then we have 7 plus 6 will give us 11. Now this is both over the 11. And we're done because if we notice that the numerator can't be factored, it is not factorable, then there's nothing left for us to do here. We can't simplify this rational. And every answer must always be simplified, and this one is done. Number 3. (3x over 8 minus 2x plus 5 over 8). Again, we notice that these are like, same denominator. We simply perform the arithmetic with the numerator. So we got a 3x here. And then don't forget, this is subtraction here. So we're going to subtract a sum 2x plus 5. So this will be minus that sum 2x plus 5. We have to put this in a parentheses here. And so, because we are subtracting a sum, we'll need to distribute. And we get 3x minus 2x minus 5 over that 8. And at this point, we're going to combine like terms. 3x minus 2x gives us simply an x. We can't combine the subtraction of 5 with anything, so we're done. So we have x minus 5 over 8. And you can't simplify this because the numerator is not factorable. Number 5. 4x plus 5 over 2 plus x minus 3 over 2. Again, we notice that these fractions here are like. We're going to add these fractions. We put them over the same denominator. This is over 2. 4x plus 5 plus x minus 3. At this point, we'll combine like terms. We take 4x plus x. That gives us 5x. Plus 5 minus 3. That's 5 minus 3. That's going to be a positive 2. Now notice at this point again, your numerator is not factorable. Even though we have 2's here, we can't simplify those 2's. Okay, we can't cancel. In other words, the cancellation property, in case you guys have forgotten, is this. In order to cancel, you have to have a product in the numerator and the denominator. So here's your cancellation property. This is when you can cancel here. But again, you have to have a product here between the two. Having a sum is not good enough here. You can't cancel. You can't use your cancellation property here. So you're done. Number 7. You have 7 over x plus 11 over x. You notice again, you have like fractions. The denominators are the same. So that means we just have to perform the arithmetic with our numerators. We just have to add here the 7 with 11, and we find again this gives us 18 over x. And again, we cannot use this cancellation property here because even though I can factor 18, it will not cancel with the x. So we're done. Final answer is 18 over x. X over x minus 4 minus 9 over x minus 4. Again, we notice we have the same denominator. These fractions are like. So we just have to put the numerators, x and 9, on top here, and don't forget your operation now is subtraction. So you're going to subtract. Now again, going back to the cancellation property, a lot of times students think that you can cancel. They mistakenly think that you can get rid of these x's, but you can't. You can't cancel those x's. The reason you can't cancel these x's here is because if you go back to the cancellation property, we need multiplication in order to cancel that term that's the same on top and bottom, and you don't have that. So what this means is that we are done. This is already simplified. Number 11, we have x minus 3 over 5 plus 5 over 2. Now, this is a situation where we notice that the denominators here are different. These are not like. So these are what we call unlike fractions. And whenever you have unlike fractions, you need the LCM of the denominators. And so the denominators here are 5 and 2. We need that LCM. And so we go with our procedure again, and we try to find a prime that goes into both of these numbers. We notice they're not, or we notice there is none. And so the LCM will be the product here of 5 and 2. So 5 times 2 is 10. This is our LCM. So we're finding the LCM of the denominators, and we're going to use this. Now, I want to note again from our past, we can give you a fact here that if I have two primes here, or two terms that are not factorable, we'll call them P and Q. The LCM will be simply the product of those two. Okay, we've seen that before, and we've just seen it right now. So we're going to use this in our future. And so now we have to go through our process here of how to add and subtract unlike rationals, or unlike fractions. Now, what we do here is we create what's called the setup, if you guys recall. We went over this in class. And down here is where we put the LCM always. 10. So here's our LCM. This is our setup. We always put the LCM down here. Now, we just have to copy the fractions here. You have x minus 3 over 5. We got 5 over 2. So what we're seeing here is that if I go back, this fraction will be equivalent to this fraction, which is the equivalent to this fraction as well. So those fractions on the left will all be equivalent. What we have to do now is determine a term that we're going to put on top and bottom here and multiply. It's the reverse of simplification. We have to determine that term or number so that these fractions remain equivalent. They're the same. And we do the same for the other side, in that 5/2 will be equivalent to another fraction, which is another fraction here. We're going to put, again, a square and a square. This is our format. We're going to try to find a term that can go there, or a number that goes in our squares, so that these fractions remain equivalent. They're the same. So here's how this works again, if you guys forgot. We're going to try to find a number. Let's remember, 5 times some number or term better be 10. The only number that'll work here is, in fact, 2. So put a 2 here and a 2 here. Similarly, 2 times some number or term needs to be 10. The only number that'll work is 5. So we have the numbers that are going to create these or convert your unlike fractions to like fractions, where they both have 10 as a denominator, and they're equivalent here. So let's erase some of this here. And so now we could do the arithmetic. Remember, when you multiply fractions, it's horizontal across. So we'll end up here with now 2 times x minus 3, which will be written like this, where 2 goes first, and then 5 times 5 is 25 here. So we can just recall that we're going to have to distribute, so you know. So do every detail. And now when we distribute here, we'll end up with 2x minus 6 over that 10 plus 25 over that 10. And then we're going to notice here that we are now in the like fraction mode here. So our denominators are now the same. So this portion here is what I call the setup that we'll have to do for every situation where our fractions are not like, where they are unlike. We follow that procedure. So now that they are like, because they have the same denominator, we can put this all over 10 here. We have 2x minus 6 plus 25, because all we did here was perform this arithmetic. 2x minus 6 plus 25. And we could combine our like terms. The only terms we can combine here are the negative 6 added with a positive 25, or added with 25, and that gives you 2x plus 19 over 10. Notice that this fraction here is a simplified rational, because you can't factor the numerator. It's not factorable, it's prime. The denominator is 10. That can be factored, but it won't cancel with anything since the numerator is prime. And this is how we handle unlike fractions. That was the detail. So number 13 here, we'll have x plus 7 over 4 minus 9/5. And again, we're going to notice that these fractions are unlike. So we have denominators that are not the same. So we'll have to find the LCM of 4 and 5. So we're going to go through our process again. We need a prime that goes into both of these numbers. And we notice that there is none. So our LCM here is actually 4 times 5, or the LCM is 20. We're going to use this as our new denominator. So let's create our setup. Down here, 20 is the LCM. And we just copy our fractions down again. X plus 7 over 4, 9 over 5. Remember, we need a term that we put here and here, and we need another term that we'll put here and here. Okay, we want to keep our fractions equivalent. And so let's remember what we do here. 4 times something better be 20. That something has to be 5. So we multiply by a 5 in the numerator and a 5 in the denominator. 5 times something better be 20. Well, that something is 4 because 5 times 4 is 20. So we're going to put a 4 in the numerator and in the denominator. And again, we just multiply horizontally across. Here, the first fraction is 5 times x plus 7, where we're going to have to use the distributive property. The second fraction as a numerator has 9 times 4, which is 36. So we'll have 5x plus 35 over 20 minus 36 over 20. Because we did use the distributive property. So now we get to simply add or subtract our numerators because these fractions are now like the LCM here, which is 20 is our new denominator. So 5x plus 35, don't forget that this is minus 20 because we have a subtraction here. And we're subtracting only one term. So this time, out of 20, you get 5x, and that's 35 minus 36, which is minus 1. And you are done. 5x minus 1 over 20. So this is the answer to number 13. Notice this fraction, this rational is simplified. So that's going to bring us, since we did 13, that brings us to 15. And we get 5 over x plus 1 plus 3 over x. We're going to need the LCM of the denominators because these fractions are not like. Okay, they're unlike fractions, x plus 1 and x. They're unlike. Now, I want you to remember here that in some sense, well, not in some sense, but exactly, x plus 1 is thought of as prime. It's not factorable. So is the x. So using our fact, we know that the LCM is going to be the product of x plus 1 and x. Or we can write this as x times x plus 1, whatever you prefer. Since they're both prime, they're both not factorable. So when we create our setup here, we need the LCM of the denominator, which is x times x plus 1. This is where your LCM goes. So let's copy what we have here. We have 5, x plus 1, 3x. We're going to have to find what to multiply my 5 by and my x plus 1 by. Multiply the 3 here and the x by in order to get the LCM on the bottom here. So notice, x plus 1 times something else. Well, we already have x plus 1 times x, so that has to be an x. Top and bottom now. X, we got the x times an x plus 1, so this has to be x plus 1. Top and bottom. So you end up with 5x here, and then 3 times x plus 1. We're going to distribute. We get 3x plus 3. and this is over x times x plus 1. These fractions are now like. And now all we do is simply take the 5x and add it with 3x plus 3. We get 8x plus 3 over x times x plus 1. And you're done. Notice 8x plus 3 is not factorable, and it won't cancel with your x in the denominator or the x plus 1 in the denominator. So this fraction is simplified. And that's number 15. Number 17, x over x plus 3 minus 1 over x minus 1. Again, I want to point out that x plus 3 is not factorable, so we think of that as prime. X minus 1 is also not factorable. We think of that as prime. So the LCM will be, with two different primes, simply the product of those primes. The LCM is x plus 3 times x minus 1. So with our setup now, the LCM down here is going to be x plus 3 times x minus 1 and don't forget to copy your fractions here. X plus 3, 1, x minus 1. We need a term to multiply on top and bottom. We need another term to multiply on top and bottom for our second fraction. Okay, and how we figure out that term is to simply look at the LCM here. We have x plus 3 times another term. We've got x plus 3. I guess that term has to be x minus 1. Has to be equivalent to the LCM. X minus 1, x minus 1. This will be times an x minus 3. I'm sorry, an x plus 3. So now this is just like the LCM. So we'll have fractions that are like. We'll have x times x minus 1 minus 1 times x plus 3. X plus 3 times x minus 1 in the denominator. And we're going to have to distribute here. And we'll get x squared minus x minus, in parentheses, the x plus 3. So don't forget, you got this numerator, which is x squared minus x. You got this numerator, which is x plus 3, over here and over here. But this time you're going to subtract the terms, so we have to put the x plus 3 in a parentheses, and we just simply use the distributive property again, because you got to get rid of that parentheses. So you have x squared minus x minus 3 over x plus 3 times x minus 1. When you combine your like terms, you get x squared minus 2x minus 3 over x plus 3 times x minus 1. So the question is whether or not this fraction is simplified. Okay, your answer is simplified. Now, what you'll have to do is factor the numerator if it's factorable. The denominator is already factored. And so when you go with your procedure here for factoring that numerator, if you guys recall, your favorite high school technique, I guess, we need the product to be negative 3, and we need the sum to be negative 2. So I need two numbers multiplied together whose product is negative 3 and whose sum is negative 2. And 3, 1, will that work? We put a negative sign for the 3. So we know what's negative 3 times 1? That's negative 3. Negative 3 plus 1 is in fact negative 2. So my numerator, when factored, becomes x minus 3, x plus 1. We use those values here and here. Don't forget that this is over x plus 3 and x minus 1. So if we double check to make sure all our arithmetic is okay, right, we have x, this is number 17, x over x plus 3 minus 1 over x minus 1. Looks like we're okay. Turns out that this is already simplified. You cannot subtract, or I should say you cannot cancel this x minus 3 and this x plus 3 because they are different terms. You can't factor or cancel x plus 1 and x minus 1 because they're also different terms. So here you go. And you're done. This is number 17. Number 19. X over x minus 3 plus 12 over x plus 4. Again, notice the denominators are factored, or not factorable. They are prime, and they are different primes, so we know the LCM is the product of those primes. It's x minus 3 times x plus 4. We're going to create our setup. And again, the LCM goes in the denominator here. X minus 3, x plus 4. LCM, LCM. In the numerator, I have x minus 3. I have 12, I have x plus 4. I need a term to multiply on top and bottom. Another term to multiply on top and bottom here. Now remember what we do here is x minus 3 times another term will be the LCM. So I already have an x minus 3. The other term has to be x plus 4. X plus 4 times another term, x plus 4. The other term is x minus 3. So now we're going to distribute here. And we'll end up with x squared plus 4x, 12x minus 36. So the numerator is going to be x squared plus 46 plus 12x minus 36 over x minus 3 times x plus 4. Because we're going to take this numerator plus this numerator. That's our new numerator. And it's all over the LCM of x minus 3 times x plus 4. So at this point, we're going to combine like terms. You're going to get x squared plus 16x minus 36 over x minus 3 times x plus 4. So we have to see if this is factorable. So go back to your favorite high school technique again for factoring. You want the product to be negative 36 and the sum to be positive 16. So we're going to have to go through factors of 36. 1 times 36, 2 times 18. So this might work. Let's see if it does work. you can have negative 2 times positive 18. Let's double check. That will be negative 36 when we multiply, and negative 2 plus 18 will be positive 16 when we add. So these are the terms. X, X. We're going to use this negative 2 and positive 18. This is over x minus 3 times x plus 4. And you're going to notice that we can't cancel our terms here because they are not exactly the same. We do have multiplication here and here, that's fine, but we don't have pairs on top and bottom to get rid of and cancel. So you're done. This is number 19. 21. 3 over x plus 1 plus 2 over 3x. Now, again, in some sense, well, we're going to need here the LCM of the denominators. We have x plus 1 and we have 3x. In some sense, we can think of both of them as prime, not factorable. But we have to be careful with the one on the left here, because 3x as a term is factorable. It's 3 as a prime, it's x as a prime, so 3 times x is 3x. Well, we have to find the LCM. So what we did before, if you guys want to double check here, we had to find the LCM of the numbers separate from the letters. So let's go back and let's consider that. We can think of, since we need the LCM, of x plus 1 and 3x here. Like what was done in the past homework here. We can think that there's a number 1 in front, so we can find the LCM of 1 and 3, and then we find the LCM of the terms, and we know the terms x plus 1 and x are prime, so we can find that very easily. So our LCM of 1 and 3 we know is 3. And the LCM of the terms is x plus 1 times x. So the LCM for both of these here will be 3x times x plus 1. We just multiply those. So this is going to be used in our setup. But we have to go down to the details of finding the LCM, the work we did in the LCM video, so that we can find the new denominator. New denominator will be 3x times x plus 1. 3x times x plus 1 because it's the LCM. Three x plus 1 to 3x. We need, again, a numerator term to multiply, and the denominator. We need a term for the numerator and the denominator for the second fraction. Don't forget this is in parentheses, and we can now figure out which terms that go there in gray and green. Remember, you have x plus 1 times another term has to be the LCM. X plus 1, the other term has to be 3x. We got 3x times another term. 3x times the term has to be x plus 1 here. So now we can multiply 3x and 3. We can distribute here. We get 2x plus 2. These fractions are now like. We just add the numerators. 9x plus 2x plus 2. Combining like terms, we end up with 11x plus 2 over 3x times x plus 1. Now your numerator is not factorable. So you're done. It's not factorable on top. 11x plus 2. And so it won't cancel with the 3x or the x plus 1. So this is the answer to number 21. (23) 3 over 2x squared minus 2x minus 5 over 2x minus 2. Now we're entering questions in which we may have to factor to see what the terms are, and we're factoring the denominators here. So when I factor 2x squared minus 2x, we have to factor completely. That means the greatest common factor is 2x, and the quotient is going to be an x minus 1 here. For the next term, the greatest common factor is 2, and here the quotient is x minus 1. So at this point, we need the LCM of 2x times x minus 1 and 2 times x minus 1. And so we can go with the procedures that we did in finding the LCM in the LCM videos, where you found the LCM of the numbers 2 and 2 separate from the terms. Here you have an x term, and here the x term is missing, but we can put x to the 0 there, because that's just 1. And then here we have a third term, x minus 1, and the power here is 1 for each. So we can go about finding the LCM now. So the LCM, if we look at it this way, for the numbers, the LCM of 2 and 2, here and here, is simply 2, because they both have that power 1. It's 2 to the largest power, and 1 is largest by default. Now for the next term, for the x variable, we got x to the first right here. Let's take a look at the powers again, and x to the 0. The largest power here is 1, so this LCM is going to be x to the first power. Then we go to the x minus 1 term. 1 versus 1, and by default, the largest power is 1. So for the third term, it's simply x minus 1. So altogether, the LCM will be 2 times x minus 1. The number, the x term, and the x minus 1 term. We just multiply those together, and that's going to be our LCM. So for this question, we do have to factor the denominator so that we could determine the LCM. Now, do not do the following. Don't multiply 2x squared minus 2x with the 2x minus 2 and say that that's the LCM, because we know it's not. Okay, you're going to have to be very careful here, and you're going to have to go through with the procedure. So people try to do that. They just want to multiply the denominators all the time. And that's not going to give you your LCM. It'll give you a common multiple, but it won't give you what's called the least common. The least common is going to be, interestingly enough, the less work in your process. So remember, we got a couple of unlike fractions we have to subtract. We need to use the LCM. It'll give you the least amount of work. So we put the LCM in the denominator here. 2x times x minus 1, the LCM. All you have to do again is copy the numerators. 3, and I'm going to keep this 3 here, and I'm going to use this denominator, 2x times x minus 1. It's going to help me see everything better. 2x times x minus 1. And over here, we're going to use the 5 over 2 times x minus 1. It'll help me see everything better as well. Again, we need to find a term that multiplies top and bottom here, and a different term for this fraction. And now it'll be a lot easier to find those terms because I know that 2x times x minus 1 times another term better be the LCM, the least common multiple. And we already have a 2x. We already have an x minus 1. So that means a 1 goes here and here. We just multiply. So this denominator will be equivalent to the LCM. The second fraction, 2 x minus 1, we got a 2, we got an x minus 1. This one needs an x, because that x term is missing right here. So that's the x that we have to use, or we should say that's the term we use on top and bottom. Now we just multiply, and 3 times 1 is 3. 5 times x is 5x. This is all under the same denominator, 2x, x minus 1, we get 3 minus 5x. Notice the numerator is not factorable, so you are done. There it is. This is number 23. (25). 3x over x squared minus 9 plus x over x plus 3. Remember, these fractions are not like. The denominators have to be factored. This one is prime, x plus 3. But the first denominator is a difference of perfect squares. We can write that as x plus 3 times x minus 3. So now we need the LCM of x plus 3 times x minus 3 and x plus 3. So we can think of this as, let's note, since we need the LCM, of x plus 3 times x minus 3 and an x plus 3 here. We can think of this as, in terms of the ideas we looked at in the LCM video or in class, we can call this a x plus 3, we can call that a prime. Since x plus 3 is not factorable, you can call it w. Here's the same prime w again. And we have x minus 3, that's another prime, we can call that one k. So we're really trying to find the LCM of wk and w. And if you guys remember, there was various ways to do that. We can use here the technique that we've been doing, finding a prime, in this case a prime term, that divides both. W divides both, and we know wk divided by w is k. And w divided by w is 1. And we know that we need a prime again that divides both of these terms, k and 1, and we find there is none. So your LCM is going to be here, simply w times k times 1, or simply wk. Now, that's not what we were given. So our LCM will be w times k, which is simply x plus 3 times x minus 3. So this is what we're going to use here to add these unlike fractions. We're going to use it as part of our setup. Okay, let's write the setup down. So our LCM is going to go down here. X plus 3, x minus 3. X plus 3, x minus 3. We got the LCMs. If we copy our numerators here, 3x, and we're going to use these terms, 3x over the x plus 3, x minus 3. And for the second term, we're going to use the x over x plus 3. So I multiply top and bottom by one term, top and bottom for the second fraction with another term. And we could determine what terms are there because x plus 3 times x minus 3 has to look like the LCM or be equivalent to the LCM. That leaves us just with the number 1 because 1 times anything is itself. X plus 3 times another term better be x plus 3 times x minus 3. Well, that's simple. This has to be an x minus 3. So we can now multiply 3x times 1 is 3x. Distribute, we get x squared minus 3x. So these fractions are now like, I get 3x plus x squared minus 3x, everything over x plus 3 times x minus 3. We can now combine our like terms. So don't forget, 3x, let's undo that. 3x minus 3x cancels, and we just have x squared over x plus 3 times x minus 3. And you're done. There you go. This is number 25. (27) 6 over x plus 4 minus 2 over 3x plus 12. Again, we have to factor where we can. Here's where you factor this denominator, 3 times x plus 4. So we're going to need the LCM of this first x plus 4 and then the next 3 times x plus 4. So there's a couple of ways you could look at this here. We say, well, what's the LCM? We can say this is 3 to the 0 power, that's 1. Is that right? And when we compare terms, the LCM will be equal to 3 to the, let's compare the powers. 0 versus 1 gives you a what? 1. 1 versus 1 is also 1. So here's our LCM. Three times x plus 4. So we're going to do the setup here. Six x plus 4, 2, and again I want to use the factored version because it helps us see everything. So remember, 6 over x plus 4, 2 over 3 times x plus 4. And the LCM has to be down here, which is 3 times x plus 4. And we need a term to multiply on top and bottom, top and bottom. So at this point, we need 6 multiplied by some term, and we can look at this x plus 4 down here and x plus 4 times another term. That term has to be 3. So we're going to multiply that 6 with 3. We got 3 and 3, x plus 4 and x plus 4. It's already the LCM, so multiply this by 1. 6 times 3 is 18, and 2 times 1 is 2. So we have 18 over 3 times x plus 4 minus 2 over 3 times x plus 4. Now 18 minus 2 gives you 16. This is over 3 times x plus 4. Now we notice that this fraction is simplified because 3 doesn't go into 16, and certainly x plus 4 also doesn't go into 16. So we're done. We got a simplified rational. That's 27. Let's see, 29 now. 3 over x plus 2 plus 7 over x plus 2 squared. Again, these fractions are not like. We're going to need the LCM of the denominators, x plus 2 and x plus 2 squared. Now, we can recall here from the past that we can let x plus 2 be w, and x plus 2 squared then is w squared. So we need the LCM of w and w squared. Remember, the LCM is going to be the variable to the largest power, so that's actually w squared. But in this case, w is x plus 2, so that'll be x plus 2 squared. So here's our LCM. This is what we're going to use. For the setup, the LCM goes on the bottom, x plus 2 squared. And then on top here, we have 3 over x plus 2 and 7 over x plus 2 squared. So on the top here, we have a term and a term for the first fraction, and the second fraction we have these terms. So we're going to have to find a term that multiplies with this x plus 2, so they get x plus 2 to the second power. That has to be another x plus 2. We need a term to multiply to x plus 2 squared to make it x plus 2 squared. Again, that happens to be the number 1, because 1 times anything is itself. We can distribute and multiply. So we get 3x plus 6 over x plus 2 squared plus 7 over x plus 2 squared. X plus 2 squared is in the denominator here. And now we have 3x plus 6 plus 7 is in the numerator. We can combine like terms. We end up with 3x plus 13. And this is not factorable, so we're done. Meaning the 3x plus 13 is not factorable. (31) 3x over 4x minus 20 plus 9x over 6x minus 30. Again, we want to make sure we have to factor your denominators. And we factor completely. So the greatest common factor of 4x and 20 is 4. The quotient's x minus 5. Greatest common factor is 6x minus 30. GCF is 6 here. Quotient's x minus 5. So we need the LCM now of these two terms. Now, we do them separate. So the LCM of 4 and 6 is the first LCM to determine. We need a prime that goes into both. 2 goes into 4 twice. 2 goes into 6 3 times. We can't repeat the process, so we're done. The LCM for the numbers is 2 times 2 times 3, or my LCM will be 4 times 3, which is 12. That's for the numbers. Now, since the terms here have the first power, the LCM for the term is going to be x minus 5 to the first power, which is just x minus 5. So for both, your LCM is 12 times x minus 5. This is going to be the LCM for both terms. For the numbers, it's 12. For the x minus 5 term, it's x minus 5. For both, it's 12 times x minus 5. Let's continue with the setup. 3x, 9x. This will be 4 times x minus 5. And 6 times x minus 5. Here's your LCM. 12 times x minus 5. So we need a term to multiply on top and bottom here. Top and bottom over here. So we take a closer look and we get 4 times 12, or I should say 4 times some number better be 12. We know that has to be 3. We already have an x minus 5 term, so we're done. 3 on top and 3 on bottom. 6 now times some number is 12. That has to be 2. We already have an x minus 5 term. So this gives us 9x and 18x. These fractions are now like. So we can add our numerators together. And we have 12 times x minus 5. So 9x plus 18x over here. 9x plus 18x, that gives you 27x. Times x minus 5. And you're done. Number 33. X squared minus 4x plus 4 plus 10 over x squared plus x minus 6. So again, you have to factor here. So x squared minus 4x plus 4, we know when you factor is x minus 2 times x minus 2. And x squared plus x minus 6 will be x plus 3 times x minus 2. We're going to need the LCM here of the denominators. Okay. Now, we can look at it this way. We need the LCM of x minus 2 times x minus 2 is x minus 2 squared. And you have x plus 3 times x minus 2. So we can find the LCM here of these terms very simply. I'm just going to remind you that what I can do here is I can put an x plus 3 term as long as it's to the 0 power. Because x plus 3 to the 0 is 1, so I'm really going to look for this here, x minus 2 squared, and x plus 3 to the first power, x minus 2 to the first power. So that your LCM will be here, x plus 3 to the largest power, x minus 2 to the largest power. So for the x plus 3, we compare 0 with 1, and we find 1 is the largest. For the x minus 2, we compare 2 and 1, and we find again 2 is the largest. So in short, my LCM will be x plus 3 times x minus 2 squared. Here's my LCM. So we're going to have to do our setup here. Okay, the LCM goes on the bottom here. X plus 3, x minus 2 squared. And I just copy my fractions. 3x as a numerator, 10 as a numerator, and don't forget we're going to use these denominators here. X minus 2 squared, and x plus 3 times that x minus 2. Okay. We need a term to multiply top and bottom. We need another term to multiply top and bottom. So we're going to have to find those terms. We just have to look at the LCM here. So x minus 2 squared, we got x minus 2. This is an x plus 3. And then this is an x plus 3. We got an x minus x plus 3 here, an x plus 3 here. We got an x minus 2 to the first power, but an x minus 2 to the second power. We need an x minus 2. That will make the denominator look like the LCM. So at this point, we get to multiply our terms, and we say 3x times x gives us 3x squared, and 3x times 3 gives us 9x. 10x minus 2 gives you 10x. 10 times minus 2 is minus 20. So x plus 3, x minus 2 squared. We're going to take the 3x squared plus 9x. We're going to add it with the 10x minus 20. So combining like terms, we end up with 3x squared plus 19x minus 20 over x plus 3. Let's go back. Times x minus 2 squared. Now, we just have to make sure that your fraction here is simplified, and the numerator may or may not be factorable, but I know one thing for certain. Even if it is factorable, it won't have an x plus 3 term. It also won't have an x minus 2 term. Because the greatest common factor of my numerator polynomial there is 1, so that means I have to factor that 3x squared plus 19x minus 20, and it's not going to be either of these factors. So the point is, I'm done because there will be no division there of those two terms on the bottom. There will be no cancellation. So we can't cancel. You're done. And this is the answer to number 33. X over x squared plus 5x plus 6 minus 2 over x squared plus 3x plus 2. You have to factor your denominators. So we get x plus 3 times x plus 2 for the first one. We get x plus 2 times x plus 1 for the second one. And I'm going to write it in reverse just for demonstration purposes here. We're going to say x plus 1 times x plus 2. And again, we're going to need the LCM of my denominators here. Okay. So when we find the LCM, we could do a couple of things here. I want to point out to you that you have an x plus 3 term here, but you don't have one over here. So I'm going to put down x plus 3 here. That's the first power. We'll put down an x plus 3 here to the 0 power because it's not on the right side, or the second fraction. We have an x plus 2 here. Oh, and we have an x plus 2 over here. Let's go back here. So we started this off by notating that you have an x plus 3 term on the left here, but you don't have one on the other side, or the second fraction. They both have an x plus 2. This is going to be the first power. And then this x plus 1 is on the right, but it's not on the left. So this is going to be x plus 1 to the 0 power here. So I want to remind people that if a term is missing, just simply put it to the 0 power like we did for both of these, so that you can actually know that anything to the 0 power is 1. So when we find the LCM by simply comparing terms and finding the term with the largest power, we can just write down x plus 3, x plus 2, x plus 1, and we can find the largest power now. So if we focus on the powers here, for the x plus 3 term, 1 and 0, we know that 1 is the largest power. We're just going to compare the powers of the terms. For the x plus 2 term, you have 1 and 1, so by default, that's a 1. For the x plus 1 term, we compare 0 with what's here is 1. We find the largest power again here will be 1. So that my LCM really is x plus 3 times x plus 2 times x plus 1. This is what we're going to use. We're going to use this. This is our least common multiple. So now we do our setup. Fraction plus another fraction. LCM goes down here, which is x plus 3, x plus 2, x plus 1, x plus 3, x plus 2, x plus 1. We have x over x plus 3 times x plus 2, and we have 2 over x plus 1 times x plus 2. So we need a term to multiply to both numerator and denominator so that my denominator looks like the LCM. Here we go. X plus 3 is down here. X plus 2 is there. What is missing is the x plus 1 term. X plus 1, x plus 1, x plus 2, and x plus 2. What's missing is the x plus 3 term. We now get to multiply. We get to distribute. X squared plus x over x plus 3, x plus 2 times x plus 1 plus, we'll put it here, x squared plus x, 2x plus 6, so it's there. X plus 3, x plus 2, x plus 1 in the denominator. We just now have to add our numerators of x squared plus x plus 2x plus 6. So we're going to add these terms here. X squared plus x plus 2x plus 6. Your final answer is going to be x squared plus 3x plus 6. And that's going to be over x plus 3, x plus 2 times x plus 1. We notice our numerator is not factorable, so we are done. This is number 35. (37) 3 over x squared minus 9 plus 2 over x squared minus x minus 6. We're going to have to factor. Okay. We got the difference of perfect squares here. X plus 3 times x minus 3. We got a factor here and here. Minus 3 plus 2. So we need the LCM now of my denominators. Now again, we can compare these terms like we did before, meaning x plus 3 here. Let's see what term is missing here. We have an x plus 3, and we don't have an x plus 3 over here, so we'll put it there. We got an x minus 3 and an x minus 3. We don't have an x plus 2 for this first term, so let's be very careful here, and let's write this down. X plus 3 to the first power, x minus 2 to the first power, x plus 2 to the 0 power, since this is not there. For the second term, we have the x plus 3 not there, so we'll put that to the 0 power. X minus 2 to the first, x plus 2 to the first. We're looking at these powers here. So that when we find the LCM, all we do is compare to find which power is the largest. So when we compare, we have 1 versus 0. The answer is 1. 1 versus 1, the largest is 1. 0 and 1, the largest is 1. So that your LCM here will be x plus 3, x minus 3, x plus 2. Here's your LCM. So here we go. Let's write down the LCM here. X plus 3, x minus 3, times x plus 2, x plus 3, times x minus 3, times x plus 2. We're going to copy our fraction over here. That's 3 on the numerator here. Let's go back. 3 and 2. We got a 3. We got a 2. But this is our denominator here. X plus 3 times x minus 3. The second denominator is x minus 3 times x plus 2. We need two terms again for our first fraction, top and bottom, and for the second fraction, top and bottom. So we know that we have to multiply on top and bottom for that first fraction. We got to find the factor we multiply by. X plus 3 is here. What's missing is an x plus 2 here. X minus 3, x minus 3. X plus 2, x plus 2. What's missing is an x plus a 3. So we're going to get to multiply here. So we end up with 3x plus 6 and 2x plus 6. X plus 3, x minus 3, x plus 2 in the denominator, 3x plus 6 plus 2x plus 6. So we can combine like terms and we end up with 5x plus 12 for the numerator, x plus 3, x minus 3, and x plus 2. Notice the numerator is not factorable, so you're done. X plus 4 over x minus 2 minus x minus 7 over x plus 5. Notice these fractions again are unlike, and we can't factor the denominators. They are both prime. They're both not factorable. So that makes the LCM pretty easy. We just have to multiply those two prime factors. That's your LCM. This is what we're going to use. X minus 2 times x plus 5. So with our setup, the LCM goes on the bottom. X minus 2, x plus 5. And you just copy over your fractions. X plus 4, x minus 2, x minus 7, x plus 5. So top and bottom I need a factor. For the second fraction I need another factor. So here we go. X minus 2 times another factor has to be the LCM. I guess that factor is going to be x plus 5. X plus 5 times another factor, that factor is x minus 2. Because my denominators have to look like the LCM. Here and here again. So on top, we multiply, we have FOIL. For both of them, we have FOIL. Okay. So by the algebra now, let's be careful here. Let's note. For x plus 4 times x plus 5 here, we get x squared plus 4x plus 5x. 4 times 5 is 20. Or we get x squared plus 9x plus 20. This goes here. For the second, we get x minus 7 times x minus 2, x squared minus 7x minus 2x plus 14. So we get x squared minus 9x plus 14. So what we do now here is we take the first numerator and the second numerator, and don't forget to subtract them. We're going to subtract. Here's what this is. X squared plus 9x plus 20 minus x squared minus 9x plus 14 is over x minus 2 times x plus 5. So when you distribute here, the second polynomial, the second quadratic, we end up with x squared plus 9x plus 20 minus x squared plus 9x minus 14. Everything over x minus 2 times x plus 5. So by looking at these terms now, x squared minus x squared are gone. They cancel. We're going to combine like terms. However, 9x plus 9x will give you 18x. Positive 20 minus 14 gives you plus 6. This is all over x minus 2 times x plus 5. You notice the numerator is factorable. You can factor the numerator. You can take out the greatest common factor. 6, 3x plus 1. But even if you did do that, that 6 and 3x plus 1 doesn't cancel with my x minus 2 or my x plus 5. So you can actually just leave your answer as is, and you're done now. And this is the conclusion of these worksheets here for this exercise. This is adding and subtracting rationals. In some cases they were like, and in other cases they were unlike.